Where we left off last lesson, we started looking at rates of reaction and what this actually means in terms of chemistry. So the purpose of today's video and lesson is to use the collision theory to explain how temperature affects the rate of reaction, keeping in mind that temperature is one of the 4 factors that affect the rate of reaction. So, as I was saying, the rate of chemical reactions is affected by many factors, and I did mention 4 earlier, but over the next few lessons we are going to focus on 3 in particular. So today's lesson is focusing on temperature, but in our lessons in the future we will also look at surface area and how concentration affects the rate of reaction. So, if we start off by looking at a demonstration of glow sticks, and we're just going to play this video for you quickly. So you have an option. You can either pause the video and jump onto your activity and watch it through there, or you can just keep playing to follow on with the video.
How glow sticks work? Well, a chemical reaction occurs between 2 reactants. But the reactants are initially separated. One of them is contained in a glass vial. It's only when you snap the glass vial that the reaction can occur. As products are formed, light is released, and that's what gives glow sticks their glow. Today for this demonstration, I'm going to snap these 2 glow sticks. One of them I'll put in this beaker of ice water, and the other one I'll put in this beaker of hot water. What do you think will happen? Make a prediction.
So, from what we just saw there is this person was explaining to us that the action of snapping a glow stick to actually make it glow itself is a chemical reaction. So, let's take a look down here. So, the brightness of a glow stick isn't actually determined by how much product is being formed. However, the brightness at any point in time depends on how quickly the reaction is actually taking place. So, if we look at this diagram down below here, on the left-hand side, we have a glow stick. So we haven't done anything to it, we've just taken it out of a packet. So, the glow stick itself has the reactants inside. The moment we remove it from a packet, nothing happens, so the reactants do not release light. So, the moment we actually crack the glow stick, where you hear that little crack sound, is when that chemical reaction starts to take place. As such, you will see that the glow stick actually starts to release light, and it will start to appear as if it is glowing. The reason for this is the moment you cracked the vial, your reactants reacted together to produce your products. In this case, light was one of your products. So, knowing how the glow stick actually works, which glow stick do you predict will glow brighter the moment we pop it into?
Have snapped these other one up. What do you think will happen?
Into the either beaker of cold water or the beaker of hot water. So, which one do you think will glow brighter? The one in hot water, the one in cold water, or you don't think there's actually a difference? So, pause this video, take a moment to jump back onto your activity and answer question 1. With question 2, which glow stick do you predict will glow for longer? The one in the hot water, the one in the cold water, or you think there is no difference? So, pause this video and have a think about which one you think will glow for longer. So, what you've just done now is make a prediction. So, let's take a moment and actually see these reactions and let's observe what happens. So, once again, I will play this video. So, focus on what's happening in this video, or alternatively, you can pause this video and watch it on your own device.
For this reaction, we're going to need lights out.
So, from what you observed in that video, take a moment to pause this video and answer question 3. So summarize what you actually saw in that video in the space in activity 3. Alright, so with question 4, based on the video above, which glow stick glowed brighter? Was it the hot glow stick, the cold, or there was no difference? So take a moment, pause this video, and select your answer. With question 5, which glow stick glowed for a longer period of time? Was it the hot glow stick, the cold glow stick, or there was no difference? So pause the video, go back to your activity, and select the answer. Okay. Moving on to the explain portion of this demonstration. What do you think might explain your observations of the two reactions? Don't worry too much if you're unsure, but I do want you to hazard a guess, an educated guess as to why you think you saw what you saw. So pause the video and try and type out an explanation for question 6. Aim for about 2 to 3 sentences. Moving on to the effect of temperature at a particle perspective. So, to actually understand what we saw in that demonstration, let's actually take a look at how the particles in a chemical reaction behave when the temperature changes. So, the following interactive down below shows a solid and a gas in a container. The blue particles in the solid react with the yellow particles in the gas to form a new product. The product particles are made up of one blue particle and one yellow particle bonded together. So that can be seen on this right-hand side. So from the interactive, we can already see there are plenty of blue particles and plenty of yellow particles, and we are told that those are our reactant particles, so your starting particles, and they react together to form our product particle, which consists of a blue and a yellow particle bonded together. So you can see that they're attached. So, for the interactive, using the controls, observe how the particles behave as the temperature changes. So the interactive asks you to click anywhere to actually start it. So I won't go through this component with you in this video. So pause this video, jump onto your activity, and give it a try. So, now that you're back to this video, I assume you've given question 6 and the interactive a try. So moving on to question 7. Based off the interactive that we saw above, as temperature increases, the speed of the particles, did they increase, did they stay the same, or did they decrease? Pause this video and have a try. Moving on to question 8. According to the particle theory, as temperature increases, the energy of particles increases, stays the same, or do they decrease? Pause this video and select your most appropriate answer. So, now let's investigate how temperature affects the rate of reactions by running 3 trials at different temperatures. Collect data every 5 seconds to create a graph in the question underneath. So, what you'll need to do with this interactive is click anywhere to start, and for every 5 seconds, what we are going to do is plot our data in this space below. So what we can see here is this red one is trial 1, which is going to be shown by the data we collect in trial 1. We're then going to plot the data that we see here. So for every 5 seconds, so knowing that time is on the bottom, we know the x-axis is going to go up by 5 seconds. So every time you type 5 seconds in, so you go up by 5 seconds, a new box will be created. So we're going to go up to 30 seconds. And all you're going to do in this Y column is the number of product particles, is you are going to fill out the number of product particles that you see for trial 1. You are then going to click the blue and the green tab and do the exact same for what you see in trial 2 and trial 3 here. So first of all, we'll go ahead and we will do the same over here. So we go up by 5 seconds. So 5, 10, 15, 20, 25, and 30. And trial 3. So 5, 10, 15, 20, 25, and 30. So remember, all your data for your 3 trials for the y-axis, so your number of product particles, is what you are going to observe as you run your simulation every 5 seconds. So, please keep it as a line graph as well. That way you can actually see the trend line. So take a moment and actually play the simulation, plot your data, and see your graph being plotted as your numbers are entered. So pause this video now and give that a try. Now that you're back, moving on to question 10. From the simulation and the graph, from question 8 and question 9, from question 9, which reaction produced the greatest number of product particles in the first 10 seconds? So from the graph that's produced, we'll take a look at the data for 10 seconds. So whichever data follows this vertical line here, and you can select whether it's the high temperature, medium temperature, or low temperature. So keeping in mind, you've got your 3 temperatures. So your trial 1, 2, and 3 represent your low, medium, and high temperatures. So, for question 11, which trial had the fastest reaction rate, and how do you know this? A hint that you might want to use to help you out is use the data from your graph to actually help support your answer. Okay? And when you're thinking about question 11, please don't just write a sentence. Actually flesh out your response and maybe go with about three or four sentences using the data to support your argument, so to strengthen the point you're trying to make. So take a moment, pause this video, and write out your response for question 11. Moving on to question 12. A graph of two trials at different temperatures is shown in this space below. How does the slope, also known as the gradient, of each curve relate to the rate of reaction? So, think back to topic 1 where we started looking at graphs and what the slope or gradient tells us about our rate of reaction, and go ahead and insert the correct responses for each. So the blue options are shown for the blue box, and this teal green option for these two down here. So take a moment, pause this video, and try question 12. With question 13, what you are asked is to explain why the rate of reaction graphs, so these ones up here, or these types of graph, actually flatten out over time. So we can see they start off somewhat steeper or curved, and then up the top here we can see it starts to flatten off. Not completely flat yet, but we can see that it starts to flatten out. So can you explain why the rate of reaction graphs flatten out over time? Aim for a response that includes what you know about rate of reaction and try and use that to support your response. Aim for about 2 to 4 sentences for question 13. So pause this video and try question 13. Now for question 14. Summarize your results by completing the sentences. So we can see we have a word bank down below in blue. And based off each of these few sentences, we are going to insert the most appropriate word. So the first one here. Increasing the temperature of the reactants caused the rate of reaction to something. This is because increasing the temperature causes, first of all, the frequency of collisions to something, and the particles to collide with greater something. So ultimately, the higher the temperature, the something the reaction. So you've got 5 options below, but you're only looking for 4 of these words. So take a moment and try and drag the most appropriate answers into the spaces above. So pause it and give question 14 a try. So, moving on. Let's actually talk about the application of glow sticks, how they're used, why we use them. So, with question 15, explain why the glow stick in hot water initially glowed brighter than the glow stick in cold water. Be sure to actually describe what's happening at the particle level. So if you need to, go back up to the top and actually watch the reaction take place. So the moment this person cracks the glow sticks and places them in the water baths. So with question 15, try and aim for about 4 to 5 sentences, approximately 60 to 80 words. So pause this video and try question 15. Moving on to question 16. Why did the hot glow stick stop glowing sooner than the cold glow stick? So think about rate of reaction and temperature and how all of this is linked, and maybe make reference to the availability of your reactants, and you can even link it to how we can see that our rate of reaction curves eventually plateau or at least go flat. So think back to question 13. But with question 16, aim for about 4 to 5 sentences for a good, solid response. Now for question 17. If a third glow stick was added to the investigation but kept at room temperature, so neither hot nor cold water baths, what would you expect to see? So think about maybe when you normally crack a glow stick, what you actually observe in those instances. So for question 17, aim for 2 to 4 sentences of good quality descriptions. So pause this video and write your response for question 17. Okay. Question 18 and 19 require you to actually think about different scenarios. So, with question 18, it talks about corrosion, so rusting. So corrosion is a chemical reaction between oxygen and iron. Which will corrode more quickly? A pipe that carries hot water or one that carries cold water? Explain your response. So, once again, let's link our response to rate of reaction. How does the temperature affect our rates of reaction? And with question 18, let's aim for about 3 to 5 sentences that really nail your understanding of chemical reactions and how temperature affects our rate of reactions. So pause this video, have a think about it, and write your response for question 18. Lastly, with question 19, explain why fizzy drinks tend to go flat faster on a hot day compared to a cold day. With question 19, you can do a little bit of research about what actually happens when you open up a fizzy or carbonated drink. But please don't just try to Google this response, because I would like to see your understanding and how you would apply the concept of temperature affecting the rate of reaction to this scenario. So with this one, let's aim for a response that includes chemical reactions, considering you will be doing some research, but ultimately remember to address the question. So why do fizzy drinks go flat faster on a hot day in comparison to a cold day? So take a moment, do your research, write up your response, and when you have finished off question 19, down the bottom, approximately in this space, you will see a blue button that says, "I'm finished, show my teacher." Please be sure to click on that to turn in your work for feedback and comments.